Hello, physics students. Just wanted to give you a quick little refresher on systems of equations and point out a few little things that you want to be careful of when doing your work and showing it. You want to keep things neat and organized, as always, but also make sure that you are showing enough work so that you are not getting lost. If a negative sign lost can cause you a lot of time trying to find out where your error was. So anytime you can try to minimize these small mistakes by doing a little extra work, you're going to save yourself a lot of time in the long run. I've mentioned variables before in another video. I'm just going to mention them again. In physics, we're not going to use x and y a lot. I mean, we will use them when talking about directions and stuff in the x-y coordinate system. But a lot of times we'll be using like subscripts on variables. So we'll have a velocity. But what if we had two velocities? Well, we could call those velocities 1 and 2, right? Because they're both velocities, but they are separate variables. So like that would be like an x1 and an x2, but they're different, but we use the same v to let it know that it's velocity. The 1 and 2 represent two different ones. We could also even go further and say velocity 1 in the x direction, and we could have a velocity 1 in the y direction in this if you think of an xy coordinate system. And you could have v2x, you also have v2y. We could also have v1x initial velocity, and sometimes we use a 0 to represent initial as well. So we can have like up to 3 subscripts, but this is still a variable, okay? Now, when you have systems of equations, I want to point out that this x here has to be the same as this x here, okay? So the variables have to be the same. So this x is the same as this x, and we're going to assume this y is the same as this y. Now, if you notice, I've put them separated here, and you have some nice spacing. When I solve a system of equations, I usually use substitution. You don't have to. In fact, this problem would be easier solved with elimination, because this negative 4x really lines up with this 4x. If you add the two equations, that will fall out. You are perfectly fine using elimination. You're perfectly fine using Kramer's rule and matrices to solve systems of equations as well. So that's one of my favorites, but not the one my go-to method. My go-to method is the easiest method for that situation. However, substitution is the main one we use in physics because it's not a lot of easy things you can do with elimination. It's most of the time substitution is the best, and that's what I'll do. And I'm going to do here, and I'm going to do it. We'll do that in physics a lot. So when you're doing substitution, after you make sure you have enough equations, most of the time, 99% of the time, you need the same number of equations as unique variables. Meaning, I have a unique x and a unique y, and there's the same x and the same y. So we have just a unique x and a unique y. That's two variables, okay, in these equations. So how many equations do we have? 1, 2. 2 unique equations, 2 unique variables. Boom, you're off to the races. You can solve. And so if you have more than that, you want to be searching for another equation that you can make to make the same number of equations as unique variables. Now, occasionally you can get away with one less, but that's few and far between, and we will see 1 or 2 instances in physics where that happens, but we'll go over that when that time comes. Okay, same number of equations as variables, and we're set to go. So I'm going to pick and solve for y over here. Y? I don't know. It just seemed like the variable I wanted to go for. Could you have solved over this equation over here? Absolutely. You could put x and solve for x over here. It doesn't matter. Pick a variable that you think is the easiest to solve for in either of equations or any of the equations, and then solve for it first. Okay, so now we have negative 2y equals a negative 12 plus 4x. Divide by negative 2. Okay, we have y equals 6 plus a negative 2x. Alright, there we go. And now we can package it and send it over here. Okay, 4x plus 8, and instead of y, we're packaging this thing to send over there. 6 minus 2x equals negative 24. Alright, now what we're going to do is we're going to distribute and solve because we have one equation with one unknown. Okay, and we have negative 12x, and we have plus 48 equals negative 24. Subtract 48 from it. Okay, we have negative 12x equals negative 72. Divide by negative 12. Get x equals 6. Okay? Now, we can package this that's in this 6 back over here. This is a legitimate equation. Let's fill in and solve. 6 plus a negative 2 times 6. This equals 6 plus a negative 12. And y equals a negative 6. Alright, so our answer is 6 comma negative 6. We can plug that back in here to check in these equations if we wish. And we're good.